Assalamualaikum and salam sejahtera. We are from Team FlyHaWk would like to present our third project video on moving normal shockwave. This time, our team will assign to work on problem to build and compute a MATLAB coding for reflected shockwave inside a closed tube. We distribute our team role into three, which are lead programming, which is Fong, lead graphic designer, which is HAIKAL, and lastly lead report writer, which is led by me. As a lead programming, Fong responsible to work and discuss with the team member on how to build and design and to compute a MATLAB coding for reflected shockwave. For lead graphic designer, HAIKAL with his knowledge on GUI, responsible to apply it on MATLAB coding to improve a better graphic on it. And lastly, me as a lead report writer will ensure that each part or section in report writing will be written as neat as possible and can be understood to the reader. This equation that lists in this slide will be used into the MATLAB coding to make a calculator for the reflected shockwave. In this video, there will be three important parts, which are iteration 1, iteration 2, and demonstration to coding and calculation. Iteration 1 will be presented by me, iteration 2 will be presented by Fong, and finally demonstration and calculation presented by HAIKAL. Part 1. You can see these are the sample of coding that I took from the MATLAB. You can see there is an important equation used to make a calculator for reflected shockwave. But for now, I will not talk about how this MATLAB written, but I want to show you how this MATLAB coding works in the most simplest way using flow chart. I will start the video on iteration 1, which is before the shock. The purpose of the iteration 1 is to ensure that the value of US, which is velocity, entered by the user is high enough for M1 larger than 1, which is supersonic, so the code can proceed to calculate to the next part. User need to key in the most important value, which are P1, T1, V1 and D values into it. However, if the US value is not high enough, a message box will appear to notify the user that the flow is subsonic flow, and it will show the current value of M1 prime to the users. So the user need to key in higher value of US. If and else conditions are used for the decision making in this calculator. After it, ensure that M1 prime is larger than 1, V2, M1, M2, M2 prime, P2 and T2 will be calculated for the next part for second iteration that will be explained by Fong.
Hi everyone, I am Fong. I will present the second part of flowchart of our MATLAB coding, which continues from the first part presented by FATINI. The important part of this flowchart is our second iterative technique, which is iteration 2. Before we start getting into iteration 2, we set initial guess value of M2R prime at 1.01 for the first iteration, because this value is low enough and yet supersonic. After that, the code will start calculate USR, V2R prime, V3 prime, M3 prime, B3 and T3. V3 prime and USR are then substituted into this equation to calculate diff, which is absolute percentage difference between V3 prime and USR. At this point, the code will make decision whether to continue the iteration, depending on the value of diff. If diff is larger than 0.01, N2R prime will be added by 0.0001 and used for the next iteration. The automatic assignment of N2R prime makes the user easier to use this code to solve the problem. All the calculation steps in this iterative technique will be repeated. The iteration is ran by using while loop, so the iterative calculation will continue until diff becomes lesser or equal than 0.01 to generate high accuracy results. After iteration is stopped, the code will start calculating area by using circle area equation. Area and P3 calculated are then used to calculate F, which is force experienced by the wall, by using the force equation. Lastly, all the results will be presented through GUI, which will be presented by HAIKAL. That's all from me, thank you.
Assalamualaikum, my name is HAIKAL and I will talk about the graphic user interface and also the behavior of the flow. So if you want to create a GUI, you need to type in the guide on the command window and then choose your template that you want and then create the GUI using drag and drop method.
So for this project, you need to open the MATLAB file of project3.m and then you are required to put in the parameters, which is the pressure, temperature, velocity, and also the diameter. When you click the calculate button, you will get a message which is either subsonic or supersonic speed. For example, this is step 5, run. Then you are required to put in the pressure, temperature, velocity, diameter, and the shock velocity. This is the examples that we use for this project. So when I click the calculate button, a message is from which is the supersonic speed. This is because the M1P is higher than 1 Mach number. If it is lower than 1 Mach number, for example, I choose the shock velocity is 100, it will prompt a subsonic speed and you need to re-enter the shock velocity. This is the comparison between the MATLAB calculation and the manual calculation. So for the behavior of the airflow, we choose 9 values of US shock velocity with the interval from 600 meter per second to 1000 meter per second with a 50 meter per second interval, and then the values of P and T3 pressure and temperature 3 will be recorded and tabulated and shown on the report. All these information will be given in the report. And that's all from us. Thank you.